Hello, my name is Lee Presser. This is my show. I speak frequently to very interesting people. Some of these conversations are so exciting, so intellectually stimulating, I thought others might like to listen in. This is the reason we started recording Conversation with Lee Presser.
Welcome to Conversation with Lee Presser. Richard Mark is Amerens' Senior Vice President of Missouri Customer Operations. In that role, he is responsible for the electric and natural gas distribution and customer service operations for Ameren in Missouri. Before holding that title, he was Amerens' Vice President of Government Policy and Customer Affairs. Prior to joining Ameren in January of 2002, he spent 7 years as President and Chief Executive Officer of St. Mary's Hospital in East St. Louis and 5 years as its Chief Operating Officer. During the next 30 minutes, Mr. Mark and I will be going to talk about Ameren's ability to service its customers now and in the future. Richard Mark, welcome to Conversation.
Thank you. Thanks for having me, Lee.
So is the servicing the customer getting tougher? And I don't mean the individual customer, I mean the ability to provide them with electric service at every moment that they want electric service.
Well, the ability to provide electric service isn't getting tougher. I think the customer expectations for continuous electric is getting higher. The expectation of the customer, many people have home businesses now that run out of their homes. And they need their computers, they need the technology, and technology is really putting a pressure on the utility industry so that where it used to be if you had an outage, it was 5 minutes or a 10-minute outage, would be significant. Now momentary outages and voltage changes are more important to the average residential customer than ever before because of technology.
Mm-hmm. So you hear complaints about these momentary interruptions? Is that what you're saying?
Sometimes people will complain. You have some, but what we feel is that as technology advances and goes forward, those types of momentary and voltage changes will become more and more important to the customer. So we're looking for ways now to actually make our system more reliable, to be able to deal with those types of things in the future, and to basically, you hear people talk about the smart grid. And so by using technology on the system, we can actually sometimes use that technology to prevent those types of disruptions for our customers. And so that's what we're really looking at, is how do we do that and plan for like the year 2020. Because we feel that with the advances in technology, it's going to be really, really important to provide that service level to the customers. That's what they expect. Mm-hmm. And so I think you have to be working toward that now in order to get there by that time.
Now, you just mentioned the term smart grid,
mm-hmm.
and everybody hears this term.
Right.
What does it actually mean?
Well, it means something different to everyone. I mean, if you look at...
Is there an industry definition of smart grid, or are you serious that depending on who the talker is, that they have ideas in their head as to what a smart grid is?
I think depending on who the talker is and what the situation is, the definition changes. Mm-hmm. We look at the smart grid as basically having your infrastructure, your distribution and transmission system that is automated to a point that improves its reliability as much as possible. And by smart grid, we mean like self-healing systems, whereas if you have an outage on a part of the line, that you'll have automation there that will immediately tell you exactly where that outage is located, and then it'll send signals back to our central dispatch and tell us, is there a way to switch the load to get the outage back on for those customers without ever a person going out there. And so that's kind of an example of a self-healing system that can be done automated through the dispatch office. We have some of that now in Missouri, but the future is going to hold that almost every circuit will have some type of automated device in the future.
A car crashes into a telephone pole, mm-hmm. or an electric wire carrying pole.
Right, right.
The pole comes tumbling down.
Correct.
Wires are ripped out.
Correct.
You're saying that your system might in the future be able to work its way around and still get that electricity to some of the homes behind that down pole?
Correct. Yeah, that pole will be down, but there may be a way to reroute the electric. In some areas now, what we call it's basically referred to as like a loop system, where then area is served in two different directions. And so sometimes what we can do is isolate where that actual pole is down and the wires are broken, and then we can serve a certain number of those customers by providing the electric from a different direction, maybe a different feeder, a different substation. And we won't get everyone back on, but we will get a large percentage of those customers on. And that's what customers want, because you can take a down pole, may take 4 hours to repair. If we can get 80% of those customers back on within 5 minutes
with the loop system,
it's something that is very, very desirable to our customers, improves customer service, and at the same time, you know, a lot of businesses depend on that electric being there for them.
Mm-hmm. I don't think your customer or your advertisers do a good enough job of explaining what you just said to the customers. It
Right.
might be that you'd want to use some animation to explain to people what it is that you're doing, because this sounds like 10, 15 years ago was impossible, and now you're doing this.
Right. Well, we do this. You're right. And we try to take out programs. We have some programs developed. We take them out to schools and talk to business groups about how the system actually works. We actually have a demonstration that we use where we use infrared technology to where we can, from a van or on the ground, a lineman can basically use an infrared camera, shine it on the transformers, point it at the transformer or one of our lines, and identify if there's excess heat, for example, around the connection, which means that there's some corrosion there or a loose connection, and make a repair before we ever have an outage. And we have these infrared systems that we are going out throughout Missouri. We utilize that, what we call a circuit inspection program, to really stop outages before a customer even knows that it could be one. And so, you know, there's all types of new technology that goes on, and it's amazing. Customers really don't think about electric until they don't have it. You know, when it's on, they don't care. You know, they don't really care about how it's generated, what generates it. We were having a conversation a couple weeks ago with a group of people that didn't realize, you know, 85% of the electric generated in Illinois and Missouri is basically generated by using coal as its fuel source. So, you know, people don't really think about that until they flip that switch and there's nothing there.
Right. I mean, I've had many discussions with people who talk about, you know, green energy and alternate energy, and I'm like, yeah, well, okay, if the Chrysler plant were still open,
Right.
do you realize how many solar panels you would need to operate something like that?
Probably
I mean,
would take up about half the state of Illinois. Yes.
Right, because the amount of electricity that gets generated is enormous. Now, a lot of people don't understand this either, is that you can't, once you generate that electricity, it's got to go out and it's used.
Right.
You use it or lose it, right?
That's right.
I mean, you can momentarily save it in some capacitors.
Right.
But that's about it.
Right. Electric is used the minute it's generated. So, you know, there's some areas that you can store some in batteries, but the technology's really not there. There's a lot of work going on storage batteries that could hold, you know, vast amounts of electric. But right now, we don't have the technologies, just not there in order to do that. So we're generating the electric that is used for the lights on the show right now is being generated the minute that it's being used. So,
Right.
and that's what people don't understand. And the generation that comes from the plants flows through the transmission lines, and those are the big, usually the metal structures that you see off the side of a highway, down to the substations and then to the wires and poles that you see in your neighborhood. And some of those are above ground and some of those are underground. And you can't put every line that you see above ground underlined. Sometimes underground is just not possible. And so people really don't understand how that system works and how it's all connected together. And if you have a break in that system at any one of those points, it's going to cause a problem somewhere else down the line. And you have to basically have those, have the systems in place to identify as quickly as possible where that break is to make the necessary repairs.